In a previous video, we showed the formation of ions using Bohr models. Today we're going to show the formation of ionic compounds, and we have an example using Bohr models and then an example using electron dot structures. Our first example is using Bohr models. When we showed how to use Bohr models in the formation of ions, when we formed the cation, we showed that the cation was losing valence electrons, and we didn't really talk about where they were going. The same is true for the anion. When we formed anions, we showed that all of a sudden, magically, we gained some electrons, but we didn't really talk about where they were coming from. In the process of forming ionic compounds, we get to put those two processes together, and we're going to see where they're going and where they're coming from. We start with your basic Bohr models. The metal is usually listed first, so I'm going to go ahead and label my Bohr models so that we can follow the Bohr model through the process. The nonmetal will follow, and so then on the left will be my metal followed by my nonmetal. Now, looking on the left side of the process, remember that arrow in the middle says a process has occurred, a reaction has occurred, and everything to the right of that is the product of that reaction. So looking to the left, for our sodium, we know that there are 11 protons in our nucleus, and there are 12 neutrons in our nucleus. Sodium also has 11 electrons. There's two. Let me use a bigger size dot here. There are 2 on the first energy level, 8 on the second energy level, and then 1 on the third energy level. For chlorine, chlorine has 17 protons and 18 neutrons. Sorry, this stylus doesn't go very small. It has 17 electrons, 2 on the first energy level, 8 on the second energy level, and 7 on the outermost energy level. And then remember from previous videos, we can check our Bohr models by comparing the number of valence electrons in the outermost energy level to the group number that the element belongs to. And sodium belongs to 1A, and it has 1 electron in the outermost energy level. Chlorine belongs to 7A, and it has 7 valence electrons in its outermost energy level. So we're good to continue. So the process, remember, when we form ionic compounds, is that the cation is going to donate electrons and the anion is going to accept them. That's how they become charged. So in that process, the one that sodium wants to get rid of is going to be donated to the chlorine. And we show what energy level that it's being donated to. So there's our process. Now we're going to show the product. So nothing has changed in my nuclei. I still have 11 protons, 12 neutrons. For my sodium, what I've done, remember, is lost an electron. So I will not place that outermost electron on there. In the process of losing that electron, I gained a 1 plus charge. So I will also list that by my Bohr model. Looking at chlorine, I still have 17 protons and 18 neutrons. With regard to the electrons, what I have done is gain an electron. and I show that gained electron with an X. In the process of gaining an electron, I also gained a 1 negative charge. That is the process of forming ionic compounds using Bohr models. Sometimes we use electron dot structures to show the formation of ionic compounds. The example we'll do in the video is beryllium fluoride. Beryllium fluoride consists of beryllium and fluorine atoms. We'll start with beryllium since it has a single atom, and we'll put it towards the center of our work area here on the left. We're going to add the fluorines to each side of beryllium and show our reaction arrow. The next step is to add the electrons for the electron dot structures. So we're going to look at fluorine. It's at 7A on our periodic table, meaning it has 7 valence electrons. So we'll go ahead and place those around each fluorine atom. And beryllium is in group 2A. It has 2 valence electrons. With electron dot structures and ionic compound formation, what we see is a transfer of electrons from the metal to the nonmetal. So beryllium is going to lose both of its electrons to the fluorine atoms. We show that transfer by circling the electron and using an arrow to show its transfer to the fluorine atoms. Now we'll show the product on the right. We start with listing the metal first. In this case, the metal is beryllium. There is 1 atom of beryllium. Because beryllium donated its 2 valence electrons, it is now charged, and specifically it has a 2+ charge. We're going to add our fluorine atoms. There are 2 fluorine atoms. Each fluorine atom has a full octet because they gained a valence electron. So we surround fluorine with 8 valence electrons. Because it has gained an electron, it is now charged, and specifically it has a 1- charge. And that is how we use electron dot structures to form beryllium fluoride. Thank you for watching.